Hello, beautiful community. I will be giving a talk about BlueStore. It, unfortunately, it might be a boring one, but I think it's an important one, and I wanted to keep everyone in sync with how BlueStore is and how far it can go still in with good and even better shape. So the talk is a brainchild of that team below, which is a most recurring members of Tuesday BlueStore Upkeep and Evolution meeting. That's recently new on community calendar. We on that talk we discuss what the problems with BlueStore we observe. We discuss what actions can be taken to improve it. Here I will not talk about what BlueStore is. I think if somebody came here, it's already known that that's something that creates the most latency inside OSD. And it will remain that way, but maybe it will be less of that. We have technically sort of three customer grade object stores. And C store will be, there's transition, but I'm sure it will be a customer grade very soon. We had file store that started a long time ago. It was deprecated in Pacific and Quincy, and in Reef is completely removed. So now I'm pretty sure that if anyone is running Reef and there is a problem with storage, I know who will be fixing that. Me or us colleagues here. How long will BlueStore still exist? I don't know. I hope it will be finally phased out with C-Store. That will just be better. But for now, we still have to keep it going for some time. What we can expect? Maybe 4 releases? Something. It's difficult to predict. But in that time, we can make it better. And in the time since the BlueStore inception, it really got better. So much less bugs in dashboard. I know that's nothing, but the goal with cost and effect is good. That's the only thing good about this slide I can tell. We have a BlueStore is mature. We need to, whatever we do, we need to do it in a way that will not disrupt upgradability and stability. So it's difficult to create a good enough validation process that will be 100% sure. We're trying. Different things can happen, but we are very cautious not to misstep and not to break anything. There are 3 things. There are bugs, and here I'm thinking just about very rudimentary bugs. This is something that causes assert, segmentation fault, or related issue that needs to be immediately addressed. We got those from telemetry, and from tracker, anyone can file up ticket. But it's not that we fix every bug. Telemetry is a very good tool that helps with your tracker submitted bug, because when we see an interesting one that would make sense, but there is no volume of related events, it just goes low priority. But if telemetry says Yeah, that's something customers have problem with, then goes in the top of priority queue. And not all of them. There is my favorite example is transaction submit unspecified order. That is still there, and we have no idea even how to make it closer to give some more beef to start with it. We assume that it's just order, that's something else that we couldn't address. The other part is, I call it Upkeep, because this is technology that we got from very quick start of BlueStore. We cut some corners. We sometimes took a short path for a solution, and after a few versions, after customer clusters running for years, we just get the results. Those problems are not new. They were always with us, but we must fix them before we can continue adding new features. And Upkeep topics came from Bugzilla for legacy reasons. Again, a tracker and a Cephio mailing list. And the last part is actual features, which is something that we add specifically new that was not there. But please do not think this is a feature that's something sales team can put on a slides and go with it. No, I do not really expect BlueStore will get any new feature that will be observable in marketing sense. All improvements will be just making behave exactly as a contract would suggest, but better. Unless something else happens. And here the sources are, as I mentioned, BlueStore, Upkeep, and Evolution meeting. Just I welcome again. That's a perfect brainstorming session each week. But it's brainstorming, so if you just want to come and tell you about your exciting problem, that's fine. But if you also have solution, that's better. That's perfect. A performance meeting as usual, and self-developer submit self-developer monthly. That's. I will now quickly stroll through three bugs that we had for a long time that were bothering us because it was obvious that they do exist, but we were unable to solve them. The first one is, you might, if you check your OSD crash logs, you might notice, prevalent for a long time, O-node put problem. That's a reference counting for O-nodes, related for caching of O-nodes. And it's annoying, but not really critical in the sense that OSD will be rebooted, but usually your data will be perfectly okay. The next two bugs will make a spice on that. So how could it be that simple reference counting with auto-delete, with just something obvious, you just get an object, and when reference count goes to 0, you delete it, can be prevalent for so many versions, and we were not even able to backport it for Octopus. It's easy. We needed to have extra actions just when reference count was 2, because that object, in addition that it was reference counted, it also resided in cache. So if it was pinned, you couldn't touch it. It was somewhere. But if it was unpinned, you could do something else. But getting rid of cache required taking a lock. And that was a very good combination. we just make it impossible for us to solve. It took 9 attempts, 9 separate PRs trying to solve it. 4 of them really made it to subsequent versions until finally Igor Fedotov solved it. And not technically solved, because I do not think with that requirements it's possible to write a proper code. But he relaxed, he made a lazy unpinning from cache. And that was enough so we can shift operation enough to make it stable. Now you cannot know how many O nodes you really do have in your cache for some transient amount of time. But that's okay cost for me. And we're not able to backport it to Octopus because too many things really changed, and it would require additional work. If there is a really, we may try, but that will be not the same solution we had for Pacific and Quincy. Next one, that you definitely noticed if it happened in your OSD. Just a simple corruption. RocksDB block got corrupted, and there is no going forward. Your OSD needs to be redeployed. No way to go around it. That one has 2 root causes. One that has always existed. Just from the beginning of the code, that's the lower one. It started with BlueStore. It's related to a comment on Linux manual that you should not use direct mode with typical buffered mode at the same time. And we're not doing that. I promise you. We open the same device and we use reads, buffered and reads direct to the same block device, but never ever to the same region, except for BlueFS log, which cost us, in some cases, when you rebooted your machine, your OSD, and it started very fast again, you could not get data that you just wrote, and some BlueFS log was lost. In effect, some updates to RocksDB tables were lost, and the result is we're broken state. The other issue we injected in Nautilus when we improved, handling of memory being transferred between BlueStore part and BlueFS part. It was so far and invisible. The correlation was so impossible to know. But we broke it in a way that it became now possible if your BlueStore created a deferred write and then had to continue just because of crash. Again, that's 2 slides back. It will not know that the deferred is already stale and it should not be executed. I will save you explanation how it can happen. The PR is there. Anyone can read with examples how that can be. Needless to say, usually that override could only happen to BlueFS objects. Your data, your block data, would never be corrupted that way. But it corrupted RocksDB data, so even worse. That one is very nice. It doesn't actually, of course, say that BlueFS gets out of space and that's a problem. Obviously, if there is no space for BlueFS, nobody will expect it to work. No, this one is when you most often collocate block with DB. they have space. I mean, block still has a lot of space, but it's fragmented to the degree that BlueFS with its alignment requirement cannot get any. It was initially in Luminous, we made a flip-flop putting, transferring, gifting and reclaiming data between block and BlueFS. That was obviously horrible, 1 megabyte alignment. Then we went for 64K chunk, which was much better. It got us really far. But finally, we now have a BlueFS that's able to work on 4 kilobyte chunks. One might have asked why it did take so much time to just set a 4K BlueFS chunk. Valid question. It's initially, when we created a BlueFS, there is a starting superblock for BlueFS that it boots reading its replay log from one sector, 4 kilobytes. If the chunks were large, it was no way your log could be that big. But with 4 kilobyte chunks and space running out, it was really possible very quickly to get very fragmented BlueFS log, and it just did not fit in that space. So now, special trampolines, multi-stage booting of BlueFS log. Performance is, of course, much inferior when you get to high fragmentation, but it will not fail. So no longer we'll have disturbed nights with a cluster that is getting sequence of BlueFS NO space on multiple OSDs on the same time, because that's obvious. One is failing, then you have to shift data somewhere, and it's very fast to do the same with a lot of OSDs. So why is that important? At least that's important for me, because now I feel like I can have more time to just add new features to BlueStore. There are full features. Here are large portions of code that will give a huge quality attributes boost. And improvements are just some things that you can do on a side that's more or less required anyway, but it can, it's a secondary thing and easier, usually easier. Yeah, I know. That's a nice one. It doesn't represent anything, just an eye catcher. When we started, we went with something called stupid allocator, which actually I think is a bad name. It was not stupid, it was just simple. And it was doing its job very good. We tested a lot with that simple, wrongfully called stupid allocator. But it had problems. It created a lot of fragmentation. We noticed that our free space become fragmented. And when free space is fragmented, you really expect your new objects also will get fragmented. So performance will go down, not even bringing back the BlueFS inner space. Much before your performance got really bad, you will know it because BlueFS will tell you. Example, real life example. How will customer cluster, if it's one of yours, I'm sorry, look after considerable amount of time co-located runs? The numbers below are continuous chunks of size 1 allocation unit up to 19. And that's not error, the graph is not cut. There was zero allocation units longer than 19 kilobytes. Graphs represent the same, it's just neither a logarithmic nor linear scale represented well, because if it's 4 orders of magnitude difference, we just not have a capacity to read that properly. So almost everything in 1, 2, or 3 allocation unit sizes. Of course, that one, I got that because we had to rescue customer from space condition. I don't like that. What I would love to have, just a second, and the same goes for object fragmentation. We also can have a very continuous allocation. If you want your cluster, your OSD look like that, please select bitmap allocator. It will really do that for you. But your objects will look like this anyway. So there will be no performance gain really. The problem here is that with fragmentation, we do not really know how much of the fragmentation is on your clusters. We have that weird fragmentation score, number of fragmentation value. It's just one number. It does tell something. It may tell you how close you are to BlueFS space condition, but now it's no longer useful even for that. So we would need some histogram for that. But even if we have fragmentation, it's not really obvious how much cost there is. Because if you're running RBD and you have 4 megabyte chunks, somehow fragmented, and because they are overwritten in different times, it might be still okay. If whatever file system is being done on the other side on that RBD, if the chunks represent different files, then they really might be never an occurrence that you read them at the same time. So you're not at all affected by fragmentation in that moment. Of course, Ronen will complain because on scrap, entire objects are read, and then the scrap is slower. So I think it will be important to get some feeling and maybe only fix the fragmentation in objects that really are hot. Okay, I think that's okay. We will have a slide about Defragmentation in a second, but please let me list other topics. What else should be addressed? RocksDB. When we merged RocksDB with BlueStore, we created our own block cache. Why? Because we wanted memory management. Now our block cache is in loop with other caches, and thanks to Mark Nelson, there's a very good dynamic procedure that goes and gives most memory to the hottest regions. But it seems like that something is stinky with RocksDB block cache, because there are conditions where we don't really seem to use the block cache, but somehow giving a lot of Linux page cache, like the same amount, seems to solve the performance problem. So it would either be that we misimplemented it, and in result, we just caching data and we cannot give it back when RocksDB wants from us, or some other error. At least I would like to take a look on that. It's a long time since we took an inspection on that. But why block cache is important? It's important because iterators work slow if you do not cache your data. And iterating in RocksDB can take a lot of time, and there have been multiple complaints about, even to the degree that try to delete empty collection, this last step of removing PG, is very slow, because at the last step it tries to iterate over the collection just to check if it's really empty. And when everything is deleted, there is a lot of tombstones, it's only tombstones, it still takes a lot of time to do that. If we would, I think a good time to acknowledge that Mr. Corey Snyder has made a very good step toward improving iterators, since he made a PR that used ranged, scoped iterators that in most cases speeds things up. But if we have a problem with iterators, we might solve it with collection list dedicated solution. I don't know what it will be. An open question how to do that, and do not overturn architecture, because we really gain from having it all in one place and using RocksDB for iterate. One solution might be replacing RocksDB with SpeeDB. There is a mode in SpeeDB. It's told to me that it works, and I tested it some time ago. Let's assume it works. When you separate key stream and value stream, what it would do if we apply it specifically to O-node collection is that even if we had just tombstones in some range, it will be a very short table. It will just contain names, and names are well compressed in RocksDB. So it should be much faster. Just an idea. Another one, spillover revert. Spillover is a condition that you don't really like when you have a deployment with a very slow device, HDD, and you back it up with some part of NVMe or SSD. NVMe, I think it's not a good pair with Spinner, but HDD, SSD. And there's no space for your RocksDB data, metadata, and it has to use, at least temporarily, space on HDD. That's not the end of the world. It works. It's much slower. But the problem happens when it's just a transitional spillover. Because if you have really more data than capacity, there's nothing you can do. But if you compact a DB that is a bit larger than half of your space for DB, it can spill over to slow device. And it will stay there for a long time, because if it happened to be a compaction that was so deep and it affected so many layers, your new SST file will reside there for a long time. And spillover revert is just a concept to simply move it back from slow device to DB. There's no problem with that. As you know already, BlueFS files can reside on either of those devices. It's just about physically executing a copy and switching extents to a new shape. That can be done. The tricky part is what to copy if there has to be a decision. That one is difficult. We do not really track very well, do not distinguish hot SST tables from cold SST tables, or maybe which I expect will be the case, it might be even that parts of some SST tables are hot while others are slow, but we might disregard it just for simplicity. Some other things. Mounting BlueStore read-only. One could ask, why is that esoteric feature even here? When, for any reason, BlueStore fails and you want to rescue some PG data, it's really difficult to use Ceph object store tool to do that. For example, let's concrete example. You got that in no space, you got into real no space situation. So to continue, RocksDB needs more space and your device really doesn't have it. You cannot mount using Ceph object store tool RocksDB and extract the data because BlueStore wants first to fulfill all that pending compaction, deferred writes, and so on. So you're stuck. That point is just about making a modification, so you just get a BlueStore read-only, just keep it frozen, load it into memory. It might take a bit, no, not only memory, but RocksDB state will be in memory, and you can extract your data. Other one, OSD superblock. I'm hoping it did not happen to you, but it happened to many people. Your OSD cannot start because ever first object written to OSD by OSD is OSD superblock, and that's necessary for it to pick it, know its state, and continue. When it's broken, you're just done. I mean, I'm saying you're done. There are techniques to try to recover from this, but that's a difficult one and not always successful. Now OSD superblock, thanks again Igor Fedetov, will be located in multiple places, including RocksDB itself. So, and also code is changed in a way that object that was usually located at the beginning of the disk will now be in also possibly different places. Why it was in the, fun fact, why it was almost always at the beginning? Because that's a small object. It was written as a first object, so it takes a first allocation unit, and it was always updated at its small. It gets always into a deferred writes rules, so it just gets overwritten in place. So that's no wonder that any damage of the beginning of OSD just crashes OSD superblock. And the one of my favorites is an example how you can devolve a feature. There was really no possibility for a long time to mount BlueStore twice. We used flock, voluntarily exclusive locks, to disallow mounting BlueStore twice. But it became useless when we containerized environments, because containerization also distinguishes those locks. So if you had a nasty condition that you tried to run your container twice, you got it. And you get your superblock corrupted. This was one overrode the second one, and that's the problem. That one also solved. We now use, in addition to locking, why not, kernel level special handling is there for opening block devices. O exclusive works differently for block devices and for everything else. And I was not able to break that. But if someone is able to break that protection, please tell me. I want a protection. I will be quick here. We do have to clean up. Mount sequence is a mess. So many changes with where we stored our configurables, how we have that layered cake that we go BlueFS, RocksDB read only, then close, open again, read allocations. Thank you. That will be simplified. Also, code cleanups around free list, and a very nice feature by Gabriel Benhano, that got rid of updates to RocksDB regarding to allocations. So we now save a lot of time in KV sync thread, not updating allocation or nodes. And what I really want to do is a whole bunch of inspection additions. I don't know, either admin socket most probably or different types that I will be able. That's for me. If anyone is just curious, I need to see what my metadata looks like, and I want to be able to correlate it on runtime, and I don't want to have to run BlueStore with some test debug levels just to see how my object is structuralized on disk. That all has to reply to me what my own node is of the interest, what are shared blobs used, how is split, and so on. And the same for runtime checking, but that one also online, offline. And runtime, of course, only for caches and buffers. It's rudimentary now. It should be much better. And also valuable fragmentation report. I want a histogram and also with split with what are the hot areas, what is the possible cost of fragmentation. So with that, this is something that will most likely be done next. Defragmentation, and it will include both defragmentation of free space and objects. That should be possible to do in one run. We are thinking about having an algorithm that will just iteratively give some iterative improvements. We don't want a globalized action that we first have to run over OSD, think for half an hour, and then be out for a week. No, it has to run inline. Or maybe, if we provide better allocators and better strategies, we skip that, and new OSDs will not be so much fragmented, but only for existing deployments it will be useful. Maybe. We're thinking that maybe localized allocations will help a bit, meaning imagine that you split free disk space to some regions, and if you need space, you want to get something that is close to required allocation size, but you really want to get it close to the object you already, all the other data of the object. Believe it or not, it's not the case. When we allocate, we do not know where is the object that asks for it. The thinking is that even for spinners, if it's the same cylinder, we will be still mostly okay. The one just next to, still the same, should be okay. Of course, that strategy for solid state that doesn't really work out. There, it's more important to land, maybe not in the proper order, but on the same whatever the disk inside architecture is. So just you can read that with one swoop. And how it can be done? Either as some extra scrub level or part of write, we just don't know. And the fact that we don't know, we are now with cooperation with Google Summer of Code, and we will create a simulator. We will make simulation of some workloads as best as we can, and we will see how it behaves after months, years of trashing that data. It's because, unfortunately, BlueStore code is not good for experimentation. You really want to implement it only once. Simulator will give us possibility to test different allocators or different strategies with minimal cost. And the last one is a weird extra. If that happens to be conjured, this will be dedicated for HD disk specifically. As I'm having a problem to predict how actual latencies will be get from spinners, that's a mode that will allow you to, basically, sorry, I'm taking you, but I think I will be most doing that, trash a lot of data to cluster that only updates metadata, but when I finally want to look how my HDD will look after a year of fragmentation of data, I will just switch the mode and the real device will be plugged in and it will execute real operations. So that's a real life tester for Mark. I'm out of time.
3 months.
Oh, okay, guys. I'm very sorry. It will be fast. Next feature that should be implemented is a lazy compression. We would maybe rip off the current path of compression, get rid of all the deficiencies we get from that, and make it offline. That way we could balance how much CPU you want to use with and select only the cold spots for compression. So no longer we will get that weird situation that after a few updates, your object that should take 3 allocation units now is using 6 allocation units because that's how we organized our blobs inside. That's better on our side. And again, the same simulator from the previous part after adaptation should be able to give us prediction how good we are doing with lazy compression. Again, sorry, that would be the same. Important addition concept by Igor Fedotov. That's a custom write-ahead log. Custom means that we rip out, that's a current scenario. RocksDB is writing to write-ahead log. We have a latency here, and we can only signal a customer requester that transaction is done at the vertical line at the end. If we modify it and provide our own write-ahead log, we can squeeze it that way. We parallelly process mem tables in kvsync thread, and also in the same time we do fdata sync to the data. So it much earlier both for signaling that the transaction is finally completed, and much earlier any operation that depends on what is written here can be executed like read or anything else. That's something I might be wrong about, but the concept is to even more reduce amount of data that goes through RocksDB. We will make a special channel for pglog, and instead, like currently we put pglog updates as new key values into RocksDB, they will land either with some circular object special or maybe with write-ahead log. It's not decided, but we will offload from that critical, because I guess you know that kvsync thread is a critical part for that generates latency in BlueStore. That's a simple one that just explains that our current deferred mechanism is too crude. Imagine you append to object. You had written some data, then you append data. Now there is one sector that needs to be replaced, and that one goes into deferred mechanism, but all the rest is just allocated. It doesn't make sense, because if you have spinner, then it basically means you're guaranteed to have to visit 2 places, but you could just visit 1 place otherwise. And that can be, that's something completely different. We are thinking about making a completely new deferred mechanism that will, instead of just keeping data that is deferred in RocksDB which means it should be only for some time. Otherwise, RocksDB will have to put it into SST tables, and huge penalty will, write amplification will occur. We want to reserve a special deferred cache and add a fast partition that could be used for a long time. That way, you could have like 10, 20, 50 gigabytes that is caching your data in a slow device, and we will just allow it to keep it for as long as necessary and clean up only when with some iterative process that does it orderly. But good part is that any object that is cached, it points to sectors already allocated somewhere. So there is no injection of a weird logic. And let's say that I will skip more difficult and esoteric things.
I think we're over, Adam.
So thank you. I'm sorry.